In the last episode of Andrew Builds Stuff kinda badly, but hey, it works, I built myself a custom lighting rig to finally get my studio lights off the ground and out of the way, position the backsplash lights in a much better place, and give me options for camera and mic mounts. In this video, while I'm unfortunately a bit sick, I'm going to be finishing what I started and getting basically everything automated and also swapping out things like the RGB lighting, so let's get stuck in. First things first, the top-down camera mount. This one is actually pretty easy. I bought a tripod ball head that should match the same foot that I already use for my point and shoot camera tripod, along with a 3/8 inch 16 pitch thread bolt, and I'm drilling a counterbore hole in a fairly short strip of CLS timber, and then drill a 10mm hole all the way through so that the bolt can actually stick out the other side. That means that when the bolt is in there, I can then screw the tripod head onto the other side, and there's actually just about enough space to get a socket in there too to be able to tighten it up, just. Then I can screw the block into the lighting rig itself, basically directly over the middle of the desk. And now, as if by magic, I've got a top-down camera view. I'm planning on using the point and shoot, my Sony RX100 Mark V-A for now, both because it's kind of the only camera I have spare, it has reasonable autofocus, and it has some zoom built in. So that means if I want to show you, I don't know, a retro old, pretty cool graphics card, I can do that and I can zoom in, or we can punch out and have a super wide view if we need the entire desk. Let's say we're building a PC, we can do that. I'm pretty happy with both the widest field of view that I can get with this and the positioning in general. Now, next up is automation. As it stands, I have to unlock my phone and press a button on my home screen to turn on the two Elgato lights, and then grab this controller. In fact, since I have a top-down view, I can show you it nice and close. In fact, I can even move it up here if I really wanted. So this controller is the thing that does the main studio lights, and then I need to plug the RGB strip in. That's kind of a pain, so I think I'll kill two birds with one stone and improve the RGB lighting and automate the process. Replacing the RGB strip has been on my to-do list ever since the resistor for the 3 blue diodes right behind my head died, probably 4 years ago now. Look, I said it was on the to-do list, not at the top. This time I picked a ZigBee controlled strip. A fairly long one too, in fact. The two strips should be able to run all the way around the 4 shelves that I have here on 2 levels and give a nice sort of backlight to the wall. The strips themselves are just RGB, not RGB like the Nanoleaf ones that I have in my bedroom, but for this, these will do just fine. As usual, they have an adhesive backing, so it's just a case of sticking them to the backs of the shelves. That's pretty much it. One thing I do really like though is these little connector covers. RGB strip connectors are just awful. They have no good locating or locking features. It's just terrible. Anyway, these basically just clip over the two ends, nicely holding them together. Isn't that great? On the automation front, I already use a Home Assistant script to turn on both Elgato lights at once, so adding turn on the ZigBee RGB strip too is no problem. What I can't easily automate are the main lights. Now, if you saw my video on the software-defined radio, you might think you know where this is going, but actually just bear with me. These lights are controlled by this remote. It is a radio frequency remote, specifically 433 megahertz of radio frequency control. And that basically just means that it isn't exactly easy to just get Home Assistant to control this thing. Now, in that video, I mentioned that I was using a software-defined radio along with a truly amazing bodge job of a Raspberry Pi and a single wire to capture and replay the off signal that this remote emits. While I absolutely could spend the time to properly capture the signals that the controller emits and then work out a way to reliably and legally broadcast them, I realized that I had a potentially easier solution. I have a spare remote for these lights that I don't use because, one remote controls both lights at the same time. So I took it apart and used some of the bits that I had lying around from the response time and latency tools to kind of bodge a solution. Basically, this is an ESP32 board running ESP Home, which lets it connect to Wi-Fi and to Home Assistant. The 4 button presses that I actually need on the controller are hooked up to output pins on the ESP board, which are connected to the gate of an NPN transistor via a 10K resistor. The buttons on the controller are active low, so I needed a way to pull the button or the pin on the controller to ground, ideally without putting any power in from the ESP32, so the transistors work pretty fine. I've got the controller powered from the second 3.3 volt regulator on board these boards, which is really cool, which is just powered by the USB-C port on the ESP, although I can actually attach a 4.2 volt LiPo battery if I wanted. I don't know why I would, but I can. That is then all controlled from Home Assistant. But it's still kind of annoying to have to unlock my phone and swipe to the correct screen and then press the button, so I took it one step further. I have these Bose Zigbee switches that mostly work okay, but they drain the damn battery every 3 months. That is insane, especially considering that they're basically special order batteries. But I mean, since I've already got a 3.3 volt supply freely available to solder to, well, I just drilled some holes in the backplate and fed some wire through and then soldered them to the battery pads and to my custom board. Oh, and then I stuck it to the post too, so that I can basically now just toggle all of the lights with a single switch on the left. I can turn off just these studio lights, or the main lights, for a more sort of moody sort of scene, moody shots with the middle one, and I'm writing a script to cycle through the RGB colors with the right button. I can of course still use my phone if I want to, but having a single physical button is pretty convenient. So now that I've got my lights out of the way, all working both remotely and with a single click, I have a top-down camera mount and kind of space for a shotgun mic if I want it. Well, I must admit that I'm really happy with this. Now, ironically, we've actually just agreed to buy this house, so I might end up mounting the rig to the ceiling itself for even more floor space, but for now, I'm happy. It works exactly how I want it. It's easier to just hop in here and start making videos, and that's exactly what I'm after. If you happen to enjoy this project, feel free to let me know in the comments and subscribe if you aren't already. You can also check out the last video where I actually build the lighting rig itself in the end cards or in the cards up above. And yeah, that's kind of it for this video. If you want to support the channel, you can do so. There are a load of links in the description, including with my own hardware tools, the open source response time tool and open source latency testing tool, if you're interested in testing monitors and peripherals and all that sort of stuff. And otherwise, that's kind of it. Thanks for watching. Hope you enjoyed it. We'll see you on the next video.